Hello student, how are you? I hope you are really fine. I'm fine, thank you. So let's start today lecture. Today lecture is lecture number 13 of crystal field theory. And today lecture we will be study about crystal field theory, that how can we apply crystal field theory and tetragonal and square planar complexes. As crystal field theory applicable for tetragonal and square planar complexes? Yes, it is also applicable for tetragonal and square planar complexes. How? So let's start today in today's lecture. In this lecture, we will study how crystal field theory is applicable to tetragonal and square planar. But first of all, we should need to know the tetragonal. What is tetragonal geometry and what is square planar geometry? What will be the tetragonal geometry? Tetragonal geometry. First of all, we should need to explain tetragonal geometry. Tetragonal geometry as octahedral geometry, but only change octahedral geometry. But only change is in the two ligands. There in octahedral complexes there are six number number of central metal atom, while in tetragonal there is also six coordination number. It is equal, there is also six coordination number, but only change is that, like, that is tetragonal geometry, that is square planar, while that one is square planar, and this is one the plane, and this is above the plane, and this line is below the plane. So there will be eight faces will formed. One is from this side, one is from this side, one is from this side, one is from this four side. Similarly, four sides will be found also here. Four side will also form here. So this is octahedral geometry. But in case of tetragonal geometry, what will be tetragonal? And tetragonal, there are differences in square and the axial bond as well as the equatorial bond. These all are equatorial bond, these are equatorial bond, these are equatorial bond, these are equatorial bond. The bond that is in, that is on the axis, that is on the xy plane, that is x axis, that is y axis. So on the axis plane, that is we called equatorial, that are in one plane. But the one is the above plane and one is the below plane. These are called axial bond. The in the same plane it is called equatorial, and while on the axial it is called axial bond. So if the axial bond is larger, if the axial bond is larger, then what will be happen? Then at this show, if axial bond is larger while equatorial bond is shorter, then this geometry will be called tetragonal shape, tetragonal geometry. Or you can say that if axial bond is larger, if axial bond is larger while equatorial bond are short, while equatorial bond are short, if axial bond are shorter while equatorial are larger, then it will also be called tetragonal, because in octahedral all the bonded are same, while in tetragonal the four bonded are the same while two bonded are different from the four one. Means the axial bond as well as equatorial bond are different in tetragonal complex. So if the axial bond are short, then what will be called? This geometry is called, also called oblique geometry, oblique shape, oblique geometry, oblate, oblate, oblate geometry. Why? In case where the where when axial bond are shortened, when equatorial band are short, this is called prolate geometry, prolate geometry. are also called this is also called the oblate geometry is also called compressed tetrahedral geometry. And while the in where axial band is large, this geometry will be called elongated tetragonal geometry. Is that clear? These are about a tetragonal and tetragonal geometry, or you can say these are all about correlate and oblate geometry. Here, the square planar complex square planar geometry is square planar geometry is sorry, pen is not working perfectly, so I am changing the pen. Sorry. The geometry that is in one plane, that is only in xy plane, this when only equatorial, when only in equatorial plane, like the board, like the blackboard, these are the center. So this is for one axis, this is another axis, this is another axis, these are all in same plane, or you can see these are all in axis, these all are in equatorial. So the equatorial axis, this structure where four ligands are used, when four ligands are used, means the in all the corner in the center there is metal, when there is metal used, and all in all corner, in this corner, in this corner, in this corner, and in this corner, where here is different ligands are used, where here is different ligands are used. So these corner, so this will be formed a square planar when one ligand approaching from this direction, and one ligand approaches from this direction, one ligand approaches from this direction, one ligand approaches from this direction. It also means that all the ligands are approaching only in dx square minus y square shape orbital of centimeter atom, approaching this the orbital that are lying in dx square minus y square, the lobe of orbital that are present in xy plane. These orbital are called when the ligands are approaches to the central metal atom in this way, in dx square minus y square orbital way, so that will be formed square planar complex. Is that clear? So let's start today's topic, that how crystal field theory involved in today's topic. So let's start crystal field theory for here. Let's first we apply crystal field theory to tetragonal geometry. For tetragonal geometry, tetragonal shape or tetragonal complexes. How we can apply? If there is used central metal atom plus four ligands, but the ligand are called ligand La are 4, Y, Lb are 2, means total there are 6 ligands are used, but among them 4 ligands are same while 2 ligands are same, but these two ligands Lb ligands are different from La. It means that either La will be strong ligand or Lb will be strong ligand. One will be strong and one will be weaker. When two ligands are stronger and four ligands are weaker, tetragonal complex will be formed. Or two when two ligands are weaker and four ligands are stronger, then also tetragonal complex will be formed. So if any complex like this, if any complex like that, then tetragonal, how tetragonal complex will be formed? If lb ligand if lb ligand is stronger, if lb ligand is stronger, then what will happen? While l if lb if lb ligand are stronger than la ligand, then what will happen? In this case, why Lb are used, Lb are two ligands, so Lb will be approached to the central metal atom in only two way, in dz square orbital, because this is the this is xy plane, x axis, y axis. So the La, first La, second ligand, third ligand, fourth ligand will be approaching in this direction, while this orbital will be called dx square minus y square, dx square minus y square, because this is x axis, this is y axis, so this is called dx square minus y square. When orbital, so ligand, when La and L when these La ligands are approaching to the central atom, while this is z square, that is z, while this is z square orbital double shape, this is dz square orbital. So when lb ligand, when two lb ligands are used, are approaching to the centrometer in this way, so in this way the lb ligands, when lb is stronger than la, then what will happen? When lb ligands are stronger than la, then what will be happen? When lb ligands are stronger than la, so what will happen? lb will be a lb ligand will have high interaction, will have high interaction with the central metal atom, so that will have increase their energy. When their energy is increased, so it will be approaches effectively to the central atom, while lb has the weak ligands, so it cannot approaches effectively to the central metal atom, so it will be away from the central metal atom, while it will be towards central metal. So let's suppose there is one ligand, there is another ligand, there is another ligand, here is another ligand. So when these are four ligands are used, and in center there is center metal I, when these ligands are weaker, so the ligand will be cannot effective or effective interaction, so these ligands are away from the center metal atom. When these are away from the center, when and one ligand is above of the plane and one is inside of the plane, below of the plane, when these ligands are stronger, then what will happen? These will be on z axis. If these will be on z axis, when these ligands are stronger, so it will have effective interaction, and the ligand will be approaches effectively to the system, to the central metal atom, so these axial will be shorter. So if axial bond are shorter while equatorial bond are longer, then which geometry will be formed? Then this geometry will be called oblate geometry. Oblate shape, oblate shape or oblate geometry. In oblate geometry, lb ligands, lb bonded, or you can say in oblate geometry, axial bonded, axial are shorter than, axial are smaller than equatorial, equatorial will be larger. So this is the condition for oblate. So this is the tetragonal complex. It means that the splitting in d orbital will be like this. Splitting of d orbital will be like this. This is d orbital. So the axial bond, if tetragon, if first of all tetrahedral, if first of all octahedral splitting occur, in octahedral Eg has high energy while T2G has lower energy. So let's suppose that is dx, that is x square minus y square orbital, and that is z square orbital, that is xy, that is xz, that is yz. So what will happen if the ligand that are approaching in the z orbital, the two ligands that are approaching in that are very strong ligand and that are approaching in the way of z orbital, when they are stronger, so their energy will be increased because there is effective interaction. So further the energy of dz square, it will be increases, the z square energy will increases, while the dx square minus y square energy will decreases. X square minus y square, its energy will be decreases. Similarly, the x square minus y square among the three orbital, the xy orbital is closer to the x square minus y square because it have one x and one y, so it will be in between xy, so their energy will also decreases. Xy, while the xz and yz both have one x and one y from this orbital and one z from this orbital, so their energy will be decreased because z has high energy, that will be xz, that will be yz. This splitting will occur in a case of oblate shape, oblate geometry. Oblate geometry, also called tetrahedral, compressed tetragonal geometry, compressed tetragonal geometry. So in tetragonal geometry, in compressed tetragonal geometry or oblate geometry, this will be case on. This will be the situation. Is it clear? So while if the equatorial bonded are stronger, while the axial bonded are weaker, means axial bonded are longer and equatorial bonded are shorter. I mean that when axial, when the position, when the ligands that are in axial position, they are weaker ligands, while in case of in the four corners, in the four corner like that, in equatorial ligands, well, equatorial ligands are stronger than the axial ligand. So what will happen? The equatorial ligands are approaching effectively to the central metal atom. When they effectively to the central metal atom, what will happen? The that it will be approaches to the central metal atom effectively. So they will be, their bonded will be shorter, while the axial bond are here weaker ligand are used in axial position, so axial bonded will be longer. It cannot be approached to the central atom effectively. So that's why prolate geometry will be, prolate shape will be formed, prolate geometry. And what will be prolate geometry? In prolate geometry, what will happen? In prolate geometry, what will happen? It will happen because the dx square minus y square, it's in their energy will be increased because the ligand in this way, the ligand in this way are strong, the ligand in xy plane are stronger ligand, so their energy will increase. The x square minus y square energy is increased, while the energy of z square will decrease. Similarly, the energy of xy, because it is in between xy, it will be increase xy, while the energy of zx, xz and yz, that will be decrease, that will be same degenerate. So that will be this geometry, this distortion will be occur in prolate geometry. This distortion is also explained by John Taylor. And John Taylor distortion, after after this topic we will discuss John Taylor distortion. And John Taylor distortion, we will see that how the distortion occur in all the system, in D1 system, D2 system, D3 system, up to D10 system. We will be see clearly how is the distortion occur in different system. Gentle distortion. Also the distortion depend upon the number of electron in dx or minus y square and dz square. If electron is present in this, if one electron is present in z square, then what will happen? If electron is present in this dx or minus y square will, while absent dz square, so what will happen? Different cases are arise. So John-Taylor distortion will tell us about these all things. So after that lecture we will study, we will discuss John Taylor with details. Okay, let's proceed the topic. So how will be distortion occur in square planar geocomplex? First of all, what is square planar complex? Square planar complex is that is x-axis, that is y-axis. If let's suppose that is x-axis, this is y-axis. So if one lobe of orbital in this direction, one lobe of orbital in this direction, one lobe of orbital in this direction, one lobe of orbital in this, like the blackboard, one corner is that one corner is that when one ligand are in this corner and one ligand are in this corner and one ligand are in this corner and one ligand are in this corner. If there, if in center, let's suppose there, this is central metal atom, if these ligands are approaching in this direction and one in this direction and this one in this direction and this one in this direction, let's suppose that is x-axis, that is y-axis. So if the centimeter atom, one have the lobe like this, one have lobe like this, and one lobe has this, one lobe has this is one dumbbell and this is another dumbbell. So if ligands are interaction with this direction, so there the energy of dx square minus y square, the energy of dx square minus y square, this will be increased. And this the complex will be in one plane, in single plane, because all ligands are in single plane, in xy plane, and only xy plane, only four ligands are used in square planar complexes. So the energy of dx1 plus y square will increase. So how will be the splitting occur? Let's to see the splitting. So how will be the splitting occur? If there is octahedral splitting occur, what will be case in octahedrals? Each orbital have high energy, that is dx x square minus y square, well this is z square, this is xy xz yz. What will happen? There is two cases. All the ligands are approaching in xy direction, so their energy of xy square will be increases, that is x square minus y square, the energy will decreases. So the z square energy is there is no ligand interaction with z square, there is no ligand that are in interaction with the z square, so their energy will be decreases. But the xy, it is in between x axis, so their energy will be increased than z square. In z square there is no ligand, in z square orbitals there is no ligand approaches, while there is no ligand interaction, their interaction is zero, because this is one ligand, this is another ligand, this is another ligand, this is another ligand, while z square will be like here that. So there is no interaction, their interaction with ligand, the orbital of z square interaction with b ligand is zero. But x square is in between, one axis will be that xy plane, or xy orbital will be, one lobe will be like that, one lobe will like where will be that, one lobe will be here. So they have little bit interaction with ligand, so that's why the xy energy will be increased than z square, that will be xy, that will be xy, that will be x square minus y square, that will be z square. While these orbital, because z square has lower energy, so their energy will be decreased, because each one contains one z. So xy and xz both have same energy, so this will be attraction, this will be splitting in the square planar complex, square planar complexes. Square planar complex will be like that. Is it clear? I hope it will be clear. What are your thoughts? Okay, thank you very much. Today topic was about crystal field theory and for tetragonal and square planar complexes. I hope it will be clear. You will have not any problem. I hope you will have not any confusion. So if there is any problem, any question, you can ask me in comment section, as well as if there is if you need to explain these further, or then you can also rewind the video, you can also pause the video, you can also download the video and uh, restart the video. You will have, if you rewind the video again and again, if you listen the lecture again and again, your confusion will be removed betterly, goodly. So that's why also you can ask me in whatsapp, you can also make contact in whatsapp, while my whatsapp number will be on the first picture on youtube, my this video thumbnail, so you can see my whatsapp number from there. You can also contact me here. You will, there will also a special class will can be formed. A special class will be depend upon the where is your confusion. If there is any topic that you have problem, if there is any question you want to solve, that you need to solve them, you can contact me in whatsapp or in my gmail, so I will be help you. Okay, thank you. Please subscribe my channel. It will make me feel happy, it motivate me, so please, thank you. Best of luck, my dear student. Thank you.